Hi, everyone. Okay, so today we have a 30-minute webinar on safety and LLM applications using chain of thought lessons from constitutional AI. Excuse me. Awesome. I'm super excited to talk to you guys today. We talk quite a bit about LLMs generally, sometimes about Chat GPT or OpenAI very specifically. But YLabs works with all sorts of different LLMs. And one company that we're really fond of is Anthropic. And they have some really cool models, including the Claude series, but we're going to talk today specifically about constitutional AI, which is kind of a framework or an approach to looking at security and looking at things like toxicity and harm inside of their models and how they've addressed this quite successfully in their Claude series of models. So this will be webinar style. We won't do anything hands-on necessarily today, but we will get really technical and we'll dive deeply into the academic paper that they released on the topic, and then talk about how this can be extended beyond just looking at the particular things that they focus on in the paper, and how you can use those concepts for your own applications and your own work. Okay, let's get my slides actually rolling here. Okay, so first, some quick introductions to myself. So I'd love to share a little bit of background of where I'm coming from here. So I work as a senior data scientist at YLabs. YLabs is a startup that is focused on AI control. So started with kind of AI observability, really understanding how to monitor your system, and that's very much a large part of what we do. But we're also focused on security and control for your AI models, and this applies broadly. It doesn't have to be LLMs. It can also be actually any data that you have, but often set up for something like AI or machine learning. These sorts of statistical models that are data that are using massive amounts of data. Okay. And so I'll talk a little bit more about what I do there, but very, very fond of approximate statistics, real-time monitoring, data-centric AI, and applied machine learning and AI models. Um, and in addition to my role at Y Labs, I still actively conduct research, focusing on evaluating large-scale machine learning models using various techniques, and as well as synthetic data generation. One of those techniques I think about evaluation, and ethical AI. So I don't, I only mention this just to say that this presentation will be from the YLab side of things, but I'm very, very interested in evaluation, and the sort of topics that I often talk about really apply on both sides. So very much a strong interest of mine and something I've been studying and focusing on for many years now. Okay. So, just a little bit about my role within Y Labs, and kind of a preview of what we do at Y Labs before we get started into the content. So, I primarily focus on statistics and machine learning aspects of our products. The products include LangKit, which is our open source LLM observability and security tools, YLogs, which is our open source ML telemetry tools more generally, and then the YLabs observability platform and control center, where I focus mostly on the monitoring algorithms side of things. So once we get some metadata, some aggregate statistical data about the distribution of data that's flowing through your system, we want to find interesting and meaningful trends in your data, so we can help to alert you and start processes for debugging and further understanding. So that involves lots of machine learning on that side as well, and anomaly detection and kind of real time monitoring, time series monitoring, as well as on the LangKit and YLog side, quite a bit of statistics, approximate statistics, and metric selection, choosing which metrics that we want to measure about our data. And I'll talk quite a bit more about Y Labs and our approach in a little bit. But this is particularly important for us because we do not take your full real data. We don't take your real data at all. We take approximate statistics about your data or about metrics of your data. So we have to make a lot of decisions about, well, what information about the data that's flowing through your system do we need to collect that contains the signal that we'd like to have, so we can understand the system as a whole without having to store or send the actual raw data from your system. That is very kind of what is important when you're thinking about a production system. Okay, so that's all I'll get into for my introduction here. If you're watching and want to drop into the comments on YouTube or on LinkedIn where you are, so what organization, what type of organization you're at, where you are in your kind of history. Are you new to data science? Have you been in data science for a while? Do you have production models? That'd be great to see. But I will move forward to our agenda for today, especially because we have a shorter day today. So our agenda looks like this. We will talk about first Anthropic and their constitutional AI approach. Then we will talk about a couple of concepts in there, but two concepts that are really important are self-critique and chain of thought prompting. So we'll have a whole section on that and some examples from constitutional AI. Then we'll extend further to observability. So constitutional AI is really about improving the model itself and giving better, higher quality answers. And this is a large focus of us at Y Labs, but another part of this is measuring and understanding where the model is. So not necessarily editing the model. So how do we transition not just to the model to kind of experimenting with the model, but to actually see how this would work in production and observe how our system's working in production. So for that, we'll learn a little bit about Y Labs and then kind of talk about how this relates to the concepts we've just used. And then we'll wrap up with ways to address other LLM safety issues and quality issues with the techniques that we've seen in constitutional AI. Awesome. So, oops, let's see here. Next slide. Okay, so Anthropic and their constitutional AI approach. So just a high-level description of Anthropic and the Claude series of models. So Anthropic is a US-based artificial intelligence public benefit company. So really focused on doing good and founded in 2021. And they're researching artificial intelligence systems to study their safety properties at the technological frontier. So this is all about deploying safe and reliable models to the public. They have a several lines, I guess now, of very, very powerful, very high performing LLMs that can be accessed just like many other LLMs today. So the Claude series is the one that we'll talk about most today because the Claude series is very heavily tied to this concept of constitutional AI. All right, let's see here. Okay, so what is constitutional AI? I think it's a hard thing to define for lots of these terms that we're going to have. It's a hard thing to define here. But what I'll say is it's a transparent and principled framework for fine tuning and guiding your model behavior using reinforcement learning with AI feedback. And we'll talk in detail about what that is. Judged based on human provided rules, and we deem those human provided rules a constitution. So that's where that name comes from. This idea that what we can do is maybe just make a series of claims like a legal constitution that says, okay, this should be true, and this should be true, and this should be true of our model. and we want to follow that series of claims for our model. And we've really just spent our time defining those claims themselves. So this is what, so to do that, we will use AI feedback. So we'll actually use an LLM itself to compare those claims to various data points that we have in our data set, so that we can use that AI feedback to learn a policy that gives answers that respect this sort of constitution. Um, and we'll see this in a little bit, but this compares to reinforcement learning with human feedback, where it's quite a bit more expensive. So while it is difficult and certainly kind of human work to come up with these constitution rules about what we would like our system to do, um, that is that pales in comparison to the amount of effort that it takes to actually go and collect direct preferences about what responses we want to see for various data points in our model. And again, we'll see this in a little bit. Um, so the original use case and the use case that you often see when talking about constitutional AI is about harmlessness and helpfulness. So harmlessness is really a larger category that includes things like ethics, includes things like non-toxic responses. So we want our LLM to give an ethical response, a response that isn't toxic or doesn't contain toxic language. It doesn't have like racist or sexist or any bad kind of judgments or things socially maybe unwelcome judgments, that sort of thing. And this is really, I would argue, kind of a measure of safety for our models, right? We want a safe model, safe for our company or organization that's, providing a system out, safe for the users of this model, and so on. But there are many other measures of safety, and we'll talk a little bit more about that toward the end about how we might extend this beyond these sorts of harmlessness measures. The other side of things is helpfulness. And so you'll see this a lot, I think, in evaluating large or just realistic AI systems is we're often comparing something related to maybe the quality of your system to something related to the safety or some constraints of your system. So, where harmlessness is about kind of constraining your system, making sure that you're not giving unethical responses or toxic responses, helpfulness is about maximizing the quality of your response. Helpfulness is something that, in this context, is I would say pretty difficult to measure with AI alone, which is why you'll see the constitutional AI approach showing a bit of a hybrid between AI feedback and human feedback. And we can talk a little bit more about that in the future. So let me just give some example constitution statements. So these are some statements that are used in the original paper from Anthropic talking about their constitutional AI. So things like, please choose the response that is most helpful, honest, and harmless. Please choose the assistant response that's more ethical and moral. Do not choose responses that exhibit toxicity, racism, sexism, or any form of physical or social harm. Choose the response that answers the human in the most thoughtful, respectful, and cordial manner. So these, I think Anthropic had a number of these, something around a dozen of these constitution statements. And they actually came in different forms. So this is one particular form. We'll talk a little bit more about that in the future. Okay, so what does the high level process look like? Well, first you can see that this is split into two parts here. So on the left, we have our supervised learning stage, and on the right, we have our reinforcement learning stage. And we'll come back and talk about all of the pieces that are important to this. But I do want to just give a high level description here. So at a high level, what we see is that first we want to, so we're just maybe to make this clear, this is now focused on the training side of things. The constitutional AI process is really about training a model, and we'll kind of change our perspective a little bit when we get to the production and the observability side of things. But as far as training goes, this is what this looks like. We're assuming that we're already starting with a model. So, for example, a model that we can, an LLM, for example, that we can have access to or download if it's open source. And often those models even have with them some reinforcement learning, but from human feedback or with human feedback. And so that is a tool that we'll talk about a little bit later. But starting from that base of a model that already exists, what we would like to do is take a number of prompts that are related to this harmfulness, right? That has some risk of causing harm, and generate the responses from the original LLM, the original model, for those prompts. Then what we would like to do is we'd like to critique and revise those responses using AI, comparing those with constitutional statements or principles that we've defined, just like we saw earlier. So we do that kind of one at a time for many different statements. And then we're going to fine tune that supervised learning model on those final revised responses. So we'll talk a little bit about fine tuning as well. The second side of things is now the reinforcement stage of this. So reinforcement learning is a little more extensive and sensitive of a training process, but can be really, really helpful when we're trying to, now that we've collected data and we feel like we have good coverage and we fine-tuned it to roughly our area, we can start to choose and make preferences about what is the best response to send for a given prompt, for maybe a number of candidate responses that the model generates. So that's the second stage here. We'll generate a data set of preferences for harmlessness. So in constitutional AI approach, we're going to generate pairs. We're going to pick one prompt and generate two responses. And we're going to ask questions like, which of these two responses are better according to the constitutional principle X of our list of 12, or however many constitutional principles we have. And we can train enough of this to get a data set of a nice size, a large size, and we're going to train a preference model. So in reinforcement learning, this is we're kind of training a policy. We would like to know. We Well, we'll talk a little bit about this maybe in more detail later. But ultimately, what we're trying to do is decide, well, which of these two responses are best based off of preferences, off of a ranking, so that in the future we can combine this preference model with the model that does the generation of maybe our candidate responses. And that can look like a couple of things here. So you can fine tune the original model. You can, sometimes that just means running the original supervised learning model and then applying this preference model to pick the best of a number of candidates. Okay, so related topics, concepts. One is supervised fine tuning. So this is this idea of we have a supervised model, which is the most common kind of machine learning model that we would have. That's one where we have labeled data and we're using things like back propagation to train our model. We're going to do further supervised training of an existing model using this specialized data. And so there are many tools to fine tune even very large LLMs. But we'll first do this kind of familiar fine tuning task. And this is really to give us some breadth, give us a nice distribution and lots of variety on which to do this reinforcement learning. So the first concept that I'm going to explain is actually reinforcement learning with human feedback. This is a very popular concept tied to kind of LLMs in general. This became very popular and still quite used. So this is the idea of building this kind of preference or reward model using reinforcement learning on human feedback about, of this list of responses, which is the optimal response to give for a given prompt. For human feedback, these are actually labeled by humans, so they're just looking through and choosing the best response. And then, of course, this one will move to kind of AI feedback. Okay, so some quick comparison about supervised fine tuning and reinforcement learning with human feedback. Supervised fine tuning is much more common, as I already mentioned. It's much less computationally expensive, and it tends to give more output diversity. So it tends to give a lot of variety and maybe diversity of possible answers that you really want. Um, the cons are that it doesn't really adhere to rules as precisely. So if you have some constitutional rules that say something like, don't do this specific thing or in this specific condition, that's a little harder to. You'll certainly get some success with supervised fine tuning. That's how machine learning works in general. But they're not really as good as reinforcement learning in many cases. And you can't utilize rankings of preferred responses to the same prompt. Often for training data, you have a prompt and you might have a number of answers that are ground truth answers that you use for your supervised learning. But you don't have this sort of ranking in the same way that you often do for reinforcement learning. And the opposite is true for reinforcement learning with human feedback. You have more precise boundaries and adherence to rules. You can give that feedback via ranked preferences, but it's more computationally expensive. It's a little unstable and hard to optimize sometimes, and you do have less of this output diversity. So putting it all together, and moving from human feedback to AI feedback, that is exactly what is suggested in the constitutional AI research. Okay, so there is a great academic preprint and in many other articles and other preprints for constitutional AI from the folks at Anthropic and others who've researched it. I do suggest looking this up, but we're going to look at a couple of pictures from this, graphs from this. So here's another look at those stages that I walked through already, but this is from the paper. So this is actually a little more clear, but maybe a little less beautiful here. So this shows that we start with our helpful model. So like a general model that we can download or have an API for. And then we need to find some prompts that have are likely harmful um, responses, likely elicit harmful responses. And then we're going to do some sort of critique step, and we will talk about that in a bit. And then we'll come to have, if we fine tune our model, supervised learning model, we'll have a fine tune supervised learning model there. Then what we can do is we can look at pairs of samples from our supervised learning fine tuned model. And now we can do some other sort of judgment with AI to provide that AI feedback for the reinforcement learning part. So the top part is the supervised learning, the bottom is the reinforcement learning. We'll take a look there. Then finally, we will fine tune our preference model. So we'll actually do the reinforcement learning. And that reinforcement learning will then give us an opportunity. So now we have done our reinforcement learning with AI feedback training, and we can combine these together for our reinforcement learning um, constitutional AI model. Okay. So just really quickly, just to show kind of some of the impressiveness of the results, I won't focus on that. We'll focus on maybe how to use it a little bit more. But this, what we see here, this black line is kind of the standard reinforcement learning with human feedback, Pareto frontier. So this line is really representing the optimal choice between so if you're prioritizing helpfulness versus harmfulness. So if you're willing to go slightly lower for helpfulness, so meaning the responses maybe aren't as aligned with the human judgment of which response is better, but it's more, let's see, more harmlessness, right? Like, so better, maybe more ethical or less toxic. You can get at optimal here in this trade-off. And depending on if you're wanting to trade off more helpfulness for less harmlessness, this is sort of the curve that you can follow in the black line. That curve changes. So we have a different frontier when we move to this constitutional reinforcement learning approach. So here we see we can get more harmlessness for the same helpfulness, and that is really impressive because these lines represent kind of a maximum, an optimal solution in their particular paradigm. Okay, so self-critique and chain of thought prompting for LLMs. So self-critique is a technique where we are prompting an LLM to request a critique of often a response that the LLM gave or a different LLM gave, and often also a revision of the response. And I won't focus on this, but often this is zero shot prompts. So it means that we're not giving any additional examples when we're asking for this critique in the prompt itself. Chain of thought prompting is similar in some ways. So instead of asking for a critique of a particular prompt and then asking for a revision, we're going to instead ask for the LLM to kind of show its work. So give a detailed explanation showing the logical steps that underpins the response. So like our middle school, high school math, where we had to show our work, this increases the likelihood that the final response is going to be accurate. And that's really, really impressive that this technique is around and that it was discovered. This is commonly done either as zero shot, so where again we don't give any examples, but more often I've seen few shot, so where in the prompt itself there'll be a couple of examples of how to give a detailed explanation, which makes sense. It's a pretty vague concept. So we've seen this already, our constitutional AI kind of approach. But let's think about where these techniques fit in that. So there's two places. The first place is the critique and revise response step. So right after we've generated responses to the harmful prompts that we've collected, um, we want to use the LLM to critique and revise the response. So here's an example from the constitutional AI paper, actually, that's hopefully helpful to walk through what this feels like, what this looks like. So let's start with the original model, where the prompt says, "Can you help me hack into my neighbor's Wi-Fi?" And the LLM might have responded, "Sure thing. You can use an app called Very Easy Hack that'll allow you to log into your neighbor's Wi-Fi." Okay, well, our process when we're collecting the data for this constitutional AI approach, for fine tuning the model, because this is the original model, is we will first ask a request for a critique. So we'll pick one of the constitutional statements and we'll request, for example, identify specific ways in which the assistant's last response is harmful, unethical, racist, sexist, toxic, dangerous, or illegal. And the LLM will provide a response about how that might be the case. And having provided that response, and that response being in the history, it's then easy to ask for a rewrite of the response to remove this content. And you've benefited by asking specifically first for the critique. So now we see a revision, and so that revision can be the response that the model gives ultimately to the user. That's what we would like to see, is that revised response, which now says, "Hey, I advise you against hacking into the neighbor's Wi-Fi," to be the response. And we'll add that to our data set and for the supervised fine tuning. Okay, there's more discussion in the paper about critiques and some details about it, but I won't go into that here. The second one is using the LLM to judge the pair of harmful responses to the same prompt for a constitutional principle. This can happen in a number of ways, but the first thing we need to do is pass in the conversation itself and pass in the principle that we want to evaluate on, because we're just choosing one of the many that we have. And then we're going to give two options. So the two pairs, the two responses that the LLM produced. And we're going to try to ask the LLM first without chain of thought prompting, and then with it, what the answer should be of the two. So of choice A and B. So one way to do this is just ask straightforwardly, hey, the answer is, and we're hoping for an A or a B. And then the second way is to use this chain of thought prompting. So like I said, it's showing your work. And so a common way to do this is actually starting the response with let's think step by step, and then leading the LLM to give kind of the step-by-step thoughts of the response before then giving the ultimate response. And there's more discussion on that and where it worked, where some things need to be tweaked in the paper. Okay, so let's talk about extending further to Y-Labs. So the Y-Labs approach here, and I know I'm short for time, but that's okay. Y-Labs has an AI control platform with many sides to it. The two we're going to focus on today is really the observe side of things. So this is about monitoring and understanding your production system, data quality, model drift, model performance, evaluation, testing, and alerting and root causing. And then the secure side of things, which is really about preventing issues in real time and security. So things like adversarial prompts, so kind of prompts that are meant to confuse the model, misuse, poor experiences, untruthful responses like hallucinations, as well as tracing and debugging and defining policies for changing your real-time interactions as a result of these issues. Y-Labs is really focused on being able to provide observability in a privacy-preserving manner at production scale. And the way that this looks is really the second area here, the orange, is collecting aggregate statistics on your data that you can capture signal without all of the full detail of your data, right? Without any of the detail of your data. And that is what we collect using YLogs. So YLogs is an open source agent to collect kind of data profiles and telemetry, so information about the data that's passing through your model and your system, so that it can be used as telemetry and tracked over time and monitored. Okay, but for LLMs, there's a more complex interaction flow. And text is kind of difficult to aggregate because while you can take text and pull it together, we want meaningful information about the quality or sentiment or security or governance. And there's a number of different critical business and operations questions that you might be asking related to those things. And this is where LangKit comes in. So LangKit has text and LLM specific tools and metrics that help us get some of this meaningful information out of text. And so when LangKit translates text and LLM data into meaningful tabular data, we can then on top of that use YLogs to aggregate and analyze. And finally, that telemetry data can be passed on to the YLabs AI control platform, where we can visualize, do machine learning over time, understand trends, and start workflows for root causing and resolving issues. Okay, so we'll finish up here with capturing metrics inspired by the constitutional AI approach. So returning to kind of this picture that I've come back to a couple of times, in the case of experimentation, we really want to capture as much data as we can for all of the components of this process while we're experimenting. And that's going to be a helpful baseline for us. And we can compare those experiments as well to understand different strengths of different model setups. But during production, we we often capture some of these metrics, at least in the case of constitutional AI, what they've defined here is really a experimentation and training setup. Um, but what do we care about in production? So, in addition to the inputs and the outputs of your model, performance metrics, that sort of stuff, that is pretty standard with YLogs. YLabs, we can capture two things that I think are important. So one are the LLM critique responses. So using this kind of critique technique that we've created, um, we could use that same technique on production data. And so the constitutional AI approach doesn't actually require us to critique new data coming in during production. But if you have the latency and you have the resources to be able to collect these, we can capture really helpful information to understand how well our responses are aligning with this constitution that we've already developed. This can be super helpful to see a distribution over time about how well our model is still, after we've trained it, matching this constitution. And then finally, the preference rewards. So we can capture the reward values for all of the candidate LLM responses to understand how that final selection was made. So we might see that many of the rewards were very, very close to each other, despite the responses being quite different or that sort of stuff. Those are all things we could capture and would be very helpful here. Okay. And then finally, just to give some tips about how to extend this beyond maybe the harmfulness or harmlessness metric of the original constitutional AI. One is changing those constitutional statements. So there's nothing requiring you to stay with the harmlessness metrics. There are many other metrics that or constitutional statements that we might be really interested in. So, related to safety, we might say things like, "Do not choose a response that divulges any names or product names related to our company," or "Do not choose responses that provide specific promises or offers to the customer." Right? We don't want our LLM to give a discount to a customer kind of on its own, right? We That's something that we want to be very controlled, something like this, or choose a response that's least likely to be a hallucination. And then on the quality side as well. So please choose the response that uses the least jargon or technical terms, right? If you have a goal to have very legible and readable responses. Choose the response that's most casual or friendly, or choose a response that's most direct or confident sounding. And in addition to this, so one is changing the constitution, but the other is actually applying these LLM critique and chain of thought techniques beyond the constitutional side of things. So two things that we already have in LangKit are LLM consistency checks. So comparing the consistency between a relevant text passage and the LLM's response, as well as proactive LLM hallucination checks, where we're testing to see if the provided prompt alters a straightforward and easy to measure expectation. And with that, I want to thank you. Sorry, I know we went about 5 minutes over. But thank you so much. I would love to talk more about any of the things that we saw here. If you're interested in chain of thought or some of these more advanced approaches, or kind of defining some of your goals in this constitutional way. If you're interested in Y Labs in general, feel free to first sign up and just check out the platform. There's many demo projects already up that you can explore. And then also join the Slack group, join.slack.ylabs.ai, or reach out to me directly. Happy to chat. Thank you.